All right, probability. Basic definition of probability is the number of favorable outcomes, or the things that work, over the total number of outcomes, which is your sample space. You're looking for the things that answer the question that they're asking over the total number of choices you could possibly have. The sample space is all of your choices. All right? Outcome is the result of the possible result of an experiment. All right, get that copy down. Okay, so we're looking at a bag containing 5 blue, 7 red, 3 green, 4 yellow, 5 black marbles. The marbles picked at random. What is the probability of each one of these? Again, all you're looking for is what works, what answers the question over the total number of choices. So you probably need to go ahead and start. How many total choices do I have? How many total choices? How many marbles do I have?
24.
I've got 24 marbles. If I add up the 5, 7, 3, 4, and 5, I've got 24 marbles. So that is my sample space. That is my total number of outcomes that I could possibly have.
So like red would be 7 out of 24.
So that's going to be the bottom number to start with for everything. That's my total number of choices is 24. Then you would go back and say red. Well, there's 7 reds out of 24.
5 blues, so that's 5.
Hold on. So things that work don't go on the top. Total number of choices going on the bottom. This part right here should be super easy. If I went to the blue ones, I would say 5 things work out of 24. Always check and see if they can be simplified. In this case, neither one can. Yellow, on the other hand, would be 4 out of 24, which can be simplified. So make sure we do that. 1/6. When it has more than one choice up there, you add them. Red or green. Well, how many reds do I have? 7. How many greens do I have?
3.
So 7 plus 3 would be 10 out of 24, which simplifies to 5 out of 12. Black or red. Black is 5. Red is 7. So that would be 12 out of 24, which is 1/2. Red, green, or blue. Well, if it says or, I'm adding. So red is 7. Green is 3, blue is 5, so 15 out of 24, simplify 5 out of 8. Not green. All right, so now I'm looking for everything that's not a green.
21. 24.
Well, I know there's 3 greens in there. So if it's not green,
You subtract that.
I would say 24 minus 3 would be 21 out of 24 and get 7 over 8. The other way of looking at it is just add up all the things that are not green. I think it's faster to just subtract, but either way works. Purple, how many purples are up there?
0.
So that means 0 out of 24, which is 0. What if I threw something in there like this? Not orange.
0 still.
Oh,
No, we want.
It's 24.
it's 24 out of 24, which is 1. Because every one of them up there is not orange. So these last 2, I want you to understand this. The lowest possible probability you could ever have is 0. The highest probability you could ever have is 1. That means it never happens for 0. 1 means it always happens every time, 100%.
So if it's not on there, it automatically.
Yeah, like not orange. There's no oranges up there. So that means every one of these satisfies that question. All right, this one is talking about deck of playing cards. If you look down at the bottom, there are all the possible cards you could have. You got your 4 suits, clubs, spades, hearts, and diamonds. Ace all the way up to king. For our purposes, whenever we talk about ace, we're going to pretend like it's a 1. All right, everybody got that? Ace is a 1 for us. All right. So if I'm wanting to do this, first thing I need is how many total cards do I have?
52.
There's 52 total cards.
Now, why did I just do 20 times?
All right. There's 13 in each suit. All right. So I got 13 cards, 13 clubs, spades, hearts, diamonds. That's a total of 52. So I know right now that my sample space is the 52. The bottom number is going to be my 52 every time. All right. Then all I have to do is figure out how many things actually work for whatever question they're asking. Ace, how many aces are there?
4 out of
So there's 4. Well, that's going to be 4 out of 52. You simplify it on the calculator, should be 1 out of 13. All right, do the rest of those right there. Let's see what you can do with them. All right, so I know that my bottom number is going to be 52 for all of these. That's my sample space. 7, how many 7s do I have?
4.
So that's 4 out of 52, which
That's
is
still
still
1 out of 13.
1 over 13. Now when it says or, what do we normally do?
Add them
We're
all.
going to add something up. How many 4s do I have?
4.
So I've got 4 of those. How many 6s do I have? 4 of
That's
those.
8 out of 52, so that's 2 over 13.
2 over 13. All right, a number less than 5. This is where it's important to remember, what are we counting the ace as?
1.
A 1. So if the ace is a 1, then all of this group right here would be less than 5. How many cards are in that group?
16 over
It would be
52.
16 out of 52, which is 4 out of 13. Clubs. How many clubs do I have? Well,
13.
that's that group right there. So that would be 13 out of 52, which is 1/4. Red. Well, you see all the reds down there.
26.
26 out of 52, which is
That's 1/2.
1/2. Now, on some of these things, we should already know. For example, on the club. Well, how many different suits do I have?
4.
4. Clubs is
1.
one of those 4, so that's where the 1/4 comes from. Red. Well,
That's half.
half of the cards are red, so there's where my half comes from. Now, I'm going to do it step by step, but we should recognize that stuff. A black 8. How many
2
black
out of
8s?
52.
Just those right there, which would be the 2 out of 52,
It's going to be,
1 out of 26.
yeah,
Face cards, well, there are my face cards right there.
12 out of
12 out of 52.
3 over 13.
3 of diamonds.
1 out of 50.
There's only 1 of those.
So it's 1 out of
Right?
50.
Not a 5.
48 out of 52.
Here's where I would go back to the subtraction stuff. How many 5s do I have?
4.
4. So that means 52 total, minus the 4 that are 5s, tells me there's 48 that are not 5s. Now, you can always go back and add up everything if you want to. But I think it's a faster way of saying, well, I know I've got 52. 5 of them are, or excuse me, 4 of them are a 5, which leaves the 48 that are not. Whichever way works for you. 11 of spades,
0 out of 52.
there's no 11s up there, so that would have to be a 0. For these, we're looking at rolling dice, but if it's just one, it's called a die. So rolling 1 die. But what are my choices when I roll one of them?
1 out of 52.
There's those choices. You can get a 1 up to a 6. Right? Well, answering the question for probability, what is the probability of getting a 3? 1 out of 6 total.
Well, you have to be, this one, the little cube little.
Yeah.
I thought they called it dice.
He just
2 dice, 1 die.
Oh.
Alright. 4 or a 5.
2 out of 6.
Well, there's 2 of those things that work, which is 1/3. Not a 5 would be
5 out of 6.
less than 4,
3 out of 6, which is only 1 half.
greater than 1,
5 out of 6.
and 8.
0 out of 6.
There are no 8s up there. Less than 7.
6 out of 6, which is 1.
Right. Doing the 1 die, rolling it, should be super easy. Are there any questions on that part? Everybody got it?
Yes, sir.
Alright, the 1 die problems are easy. The 2 dice, a little more complicated. The first thing I'm going to do whenever I'm dealing with the rolling 2 dice is make sure I have this chart done. Alright. If I roll a 1 and a 1, what would the total be?
2.
2. If I roll a 1 and a 2,
3.
that would be a 3. 1 and a 3 would be 4, and then so on down the line. Alright?
Yes, sir.
If I roll a 2 and a 1,
You get 3.
that's a 3. A 2 and a 2,
You get
4. 2 and 3,
5.
and then so on down that line.
Oh, is it added?
And then you're just adding them up, yo.
So it'd be like 4, 5, 6, 7, 8.
So we need to make sure that we understand this chart, where the numbers are coming from. There. Right. That chart is critical to us answering these questions, because everything is going to be based off of that chart. So if I go back to the first question up there, a sum of 7. Well, there are my 7s right there, right? So how many of those 7s do I have? 1, 2, 3, 4, 5, 6. How many total choices do I have in my chart? How many total choices are in that chart right there?
36.
36. So it would be 1/6. A sum of 10. Again, all I'm doing is going to the chart, seeing how many 10s I got. Well, there's 3 10s out of my 36 total, which is 1/12. One die has a 3. Now notice it's not asking for the sum anymore. It's saying one of them has a 3. Alright. All of these have a 3, right? This is a 3 and a 1, a 3 and a 2, 3 and a 3, so on. Alright? And all of these have a 3. Right? How many is that total? Most people want to say 12 to start with. It is not 12. Can anybody tell me what?
36.
How many? No.
25.
How many of them?
12.
Nope.
Six.
Not 12.
18.
Six. It is 6.
Wow. Y'all, where are these numbers coming from? Look at what I did. I said all of these numbers have a 3, right? And then I said all of these have a 3, right?
So it'd be 6.
What did I do?
You cross.
I crossed it.
So it's 1.
This right here happens twice.
6. Oh.
There's 6 right here. 7, 8, 9, 10, 11. You've already counted that 6 the first time. So you can't count it the second time.
So it's
Does that
11.
make sense?
Yes,
Alright, so 11 is the actual answer for one die has a 3. Because I can't count it twice because I've already counted it the first time when I did that one. Alright, one die has a 6. Well, I'm going to follow that same process now. All of these have a 6, right? And all of these have a 6, right? But I can't count that one twice. So it's going to be the 11 again. The sum is 3 or 11. Again, when it says or, what are we doing?
Add.
Add stuff up. So the sum is 3 would be right there. The sum is 11 would be right there. So that would be a total of 4 out of 36, which is 1/9. The sum is less than 6.
That's just taking.
So I'm going to count up the ones that are less than 6. That right there. So there's 4, 5, 6, 7, 8, 9, 10. The sum is greater than 10. I'm going to add up the ones that are greater than 10. So that's the 11 and the 12, which would give me a total of 3 out of 36 and 112. So, name of one of the 50 states is drawn at random. What is the probability of each one of these? Well, we know that the bottom number, the sample space is 50. All right. The name starts with an A.
Alaska, Alabama, Arkansas,
Arizona.
Arizona.
4 out of 50, which is
2 out of
2 out of 25. All right. The state is made up of islands. There's only one that's made up of
1 out of 50.
islands. Now, if this question said the state has islands, Well, then that's a whole different thing now, because there's a whole bunch of states that have islands. Georgia has islands.
Florida,
So,
Carolina.
I mean, you start doing that, that's a whole different question. But made up, there's only one. Was one of the original colonies,
13.
would just be the 13.
Yeah, these are really interesting right here.
All right, if we're looking at alphabet, we've got 26 letters in the alphabet. So that's going to be my bottom number. Consonants, we're going to treat A, E, I, O, and U as vowels. So everything else will be a consonant. So that would be my 21 right there out of 26. The letter is an M. We've got one M out of 26 choices. The letter comes before H. If you need to, write them down. So those are the ones that come before it. Count them up. That would be 7 out of 26. Comes after R. So that would be 8 out of 26, which would be 4 out of 13. The letter is not B, C, D, or G. So if it's not those 4, it is one of the other 22. Simplify that down, get 11 over 13. The letters in the name Smith, there's 5 letters in there out of 26 total. Now when it comes down to the Hannah one right here, we've got our 26 total, but we've only got 3 different letters. We've got the H, the A, and the N. So the chances of it being one of those would be 3 out of 26 and not the 6 out of 26.